So let's start with 2 marks question, which is first question number 9. A sample of water contains an organic compound C8H16O8 at a concentration of 10 to the power minus 3 mole per liter. Given that the atomic weight of carbon 12 gram per mole, hydrogen 1 gram per mole, oxygen 16 gram per mole, the theoretical oxygen demand of water in gram of O2 per liter, round off to 2 decimal places. The keyword which we have to note here is theoretical oxygen demand, THOD. THOD, theoretical oxygen demand. See, what is theoretical oxygen demand? First of all, we should understand that. So, if in any water sample there will be what? There will be organic matter, right? If all the organic matter, we know, if for all the organic matter, if we know the chemical formula, if we know the chemical formulas of organic matter, as well as we know the exact concentration, we know the exact amount or concentration of the organic matter, then by help of these two we can calculate theoretically that how much oxygen will be required. So we can calculate the amount of oxygen required, right? So this oxygen that we calculated, this is known as theoretical oxygen demand. Okay, so two things are needed for theoretical oxygen demand. First is that chemical formula is needed and exact concentration of the organic matter is needed. By the help of this, they calculate the oxygen demand and they says at theoretical oxygen demand, right? Now, in this question, they have given the organic compound, that is C8H16O8. We know what? We know the formula C8H16O8, and the concentration is also given 10 to the power minus 3 mole per liter. Now, theoretical oxygen demand is needed to be calculated. So, see, the reaction of C8H16 and O8 with oxygen, obviously it will get reacted to the oxygen in water. So this C8H16O8 plus O2 will react to water, will react to O2, and it will give CO2 plus H2O. If I balance it out, 8 carbons, so 8 carbons, and then 16 plus 32 plus 16, O2, here O2 are, if I put it 8 here, yes, now everything is, see, hydrogen is 16, we have to put 8 here. So this is the balanced reaction. This is how the 1 mole, I can say from here that 1 mole of this C8H16O8 will react to 8 mole of oxygen. So I can say that 1 mole of C8H16O8 reacts with 8 mole of oxygen, right? So if I say, see, the concentration is 10 to the power minus 3. So if I say that 10 to the power minus 3 moles will be reacted by how much oxygen? 10 to the power minus 3 moles of CH2 will react with 8 into 10 to the power minus 3 moles of O2, right? So the number of moles, so this much number of moles of oxygen came out, and now we know that what is number of moles. Number of moles is nothing but it is the weight in grams divided by molecular weight. Okay, weight of grams into molecular divided by molecular weight. So the amount of oxygen required, that means amount will want in grams, right? So the amount of oxygen required, that means I can say THOD required will be this number of moles of O2, into molecular weight. Okay, number of moles of O2 is 8 into 10 to the power minus 3 number of moles of oxygen. Molecular weight of O2, 2 oxygen are there, 32. So we get the amount which is 0.256 grams per liter, we can say. So the option will be 0.256 grams. They want it in 2 grams, we have given it into grams. Now let us see the next question, which is question 20. Before that, let's clear our board. All right, start. Question 20. The ultimate BOD-L0 of a wastewater sample is estimated as 87% of COD. Okay, ultimate BOD is 87% of COD. That means L0 is equal to 0.87% ultimate BOD, we are asking, of COD. Okay, COD of the water is given 300. Good. So I can calculate the ultimate BOD. 0.87 into 300 gives out to be 300 of 0.87% of 300 is 261. So ultimate BOD comes out to be 261 milligram per liter. See, BOD will always be less than COD because COD is BOD plus some biodegradable oxygen demand as well. So the ultimate BOD is 261. Now considering first order BOD reaction rate constant using natural log is 0.23 per day, the temperature coefficient 1.047, BOD value after 3 days of incubation at 27 degrees Celsius. This one thing we need to put it into the minds. See, the reaction generally will be given at 20 degrees Celsius. The reaction rate constant at 20 degrees Celsius comes out to be 0.23 per day. This is the general value. Other than 20 degrees Celsius, if any other temperature is given, just like here 27 degrees Celsius, we need to convert this reaction rate constant also according to this. Okay, and for that they give the temperature coefficient. In this question the temperature coefficient is 1.047. If they don't give, just remember it, 1.047, 1.016 rather. So these will be the correct values. Now first of all I need to get what the temperature your reaction rate constant is nothing but K. Any temperature is equal to K at 20 degrees Celsius and 1.047 to the power that temperature minus 20. So I get the value 0.23, 1.047 to the power 27 minus 27. So it comes, so the reaction rate constant at 27 degrees Celsius comes out to be 0.317 per day. Now reaction rate constant is given after 3 days. After 3 days they want BOD. So BOD 3. So BOD 3 will be equal to L0 we have already calculated. L0 1 minus e to the power minus k into t. L naught is 261. 1 minus e to the power minus 0.317 into 3. So after calculation, the value of BOD3 comes out 160.16 milligram per liter. So the answer is 160.16. We can up to 1 decimal place they want. So 160.2 milligram per liter the answer. Next is, for the given water sample, let's clear the board before doing next question. Now, the given water sample ratio between VOD 5 days and the ultimate VOD is this much. Value of reaction rate constant. We need to calculate. So this is easy. BOD 5 divided by ultimate BOD is equal to 1 minus e to the power minus k into time is 5. Okay. So BOD 5 and ultimate BOD 0.68 is equal to 1 minus e to the power minus 5k. So e to the power minus 5k is equal to 1 minus 0.68. This comes out to be 0.32. E to the power minus 5k is equal to 0.32 if we take log both sides. So minus 5k is equal to minus 1.139. So k is equal to 0.227 day inverse. I can say k is equal to 0.23. So the answer comes out to be 0.23. Up to 2 decimal place, so I have given it to 23.